Welcome to the last video of AP Computer Science A. In this video, we're going to discuss about recursion. Recursion is basically a method that calls itself. Using a recursive method, it will break the problem into smaller subproblems. And in a recursive method, there are two essential parts. First, you have the base case, which is a condition that stops the recursion. And you also have a recursive case, which the method uses to call itself with a simpler or a smaller input. Here you can see an example of a recursive method called sum, and here this conditional statement here, where n less than or equal to 0 is the base case, and here you can see this is the recursive case, where each time when it's the sum method is calling itself, it's calling it with a smaller number than -1. And you can see here that this base case right here prevents this method from running forever, because if you keep subtracting n, it will eventually go below 0 or equal to 0. So it will end at a finite amount of steps. And this base case right here prevents stack overflow, which is an error that occurs when you have an infinite loop that never ends, or in this case, an infinite amount of recursions. And what this method does is that it sums all numbers from n to 1. So you can see here, for example, when I called n, then it returns n. But on top of that, it's not only just returning n, but it's also returning n plus sum n minus 1. So what this does is that it invokes this method again, and then this return method is held until this sum method finishes running. So right here, we don't return for this sum n. We instead go into this sum n minus 1. And in this sum n minus 1, can see that we're returning n minus 1. So now after calling sum, this n right here will no longer be n, but it will be n minus 1. And this return statement right here returns n minus 1 instead of n. But it not only returns n minus 1, but it returns n minus 1 plus sum of n minus 2. And this goes on forever until you're adding m plus n minus 1 plus n minus 2 plus n minus 3, blah, blah, blah. And at the end, after every recursive method finishes running, it will go back to the initial method and it will return the sum of all of them. So here we can look at an example. So here we have a method named m and receiving in parameter n, and if n is less than or equal to 0, then it will return 1. And let's look at how this is done step by step. So for example, we called m of 5. And so here we know that m of 5 will return m minus 2 plus m minus 1. So in this case, m3 plus m4. And now we don't know the value of m5 yet, so we're going into m3 and m4. So now m4 will be n minus 2 plus m minus 1. So in this case, m2 plus m3. And m3 will be the same, which will be m1 plus m2. And m2 will be m0 plus m1. And m1 will be negative 1 plus m0. And you can see here, m1 has reached to the bottom of the recursive case, where both n is less than or equal to 0, so they'll both return 1, and m1 will result in the value 2. And now you have m1, you can calculate m2, and you will go back to the previous method, which is m2, that returns m0 plus m1. And since we know m0 is 1 and m1 is 2, we know that m2 is 1 plus 2, which equals 3. And now we can keep going, calculate m3 because we know 1 and 2, so that's 2 plus 3 equals 5. We know m4 because we know m2 plus m3, so m2 plus m3 is 3 plus 5, which equals 8. And lastly, we go back to the very top, so we now know both m3 and m4. So m3 will be 5, m4 will be 8, and 5 plus 8 equals 13. And this is how a recursive method breaks down problem into smaller subproblems. As you can see, we don't know the value of m5, but we can break it down to m3 and m4, and we keep breaking it down until we've reached a small problem that we know the value of and go back to the top to calculate the final value. And now let's look at practice questions. First, write a recursive method factorial int n that returns n factorial. So for example, factorial 5 is 120. And also please answer this question that requires you to write a recursive method fib int n that returns the nth Fibonacci number. So the Fibonacci number is a series of numbers that each element is the sum of its previous two numbers. So for example, here the third Fibonacci number 1 equals to the previous two 0, 1, which is 1. And here we'll use it by computer science traditional index. So this will be our second, this will be our 0th number. So this second element will be 0 plus 1 equals 1. And this third Fibonacci number will be the previous two summed up together. So 1 plus 1 equals 2, and so on. And we know that we need the previous two numbers to calculate the nth Fibonacci number, so we can't calculate 0 and 1, so we define them at the beginning. For the 0th and 1st Fibonacci number, we assign them 0 and 1. And for example, after finishing the method, fib5 should return 5. As you can see, 0, 1, 2, 3, 4, 5. So the 5th Fibonacci number is a 5. And here is the answer to the first question. You have factorial, and first you need to write a base case. So when n equals 0, you return a 1. If not, then you return multiplied by factorial of n minus 1. As you can see here, we're breaking down this bigger problem into a smaller problem. We know that we don't know the value of factorial. We don't know n factorial yet, so we're breaking down the problem into n times n minus 1 factorial. So in here, it's written as n multiplied by factorial of n minus 1, and we keep going like that. We don't know the value of factorial n minus 1 yet, so we calculate it by doing n times n minus 1 times the factorial of n minus 2, and so on. And for the second question, we need two base cases since we have two numbers that we're defining beforehand. So here, when n equals to 0, you return 0. And otherwise, if it's 1, then you return 1. And in the rest cases, we can calculate the Fibonacci number because we have at least two numbers in front. So you can return fib of n minus 1 plus fib of n minus 2. And for example, if we're at 8, we want to know what is the 0, 1, 2, 3, 4, 5, 6, what is the sixth Fibonacci number. We can break it down to a smaller problem, like here. What is the previous Fibonacci number and what is the Fibonacci number before the previous number? So in this case, it's 3 and 5, but we don't know yet. And for these two, we also try to calculate the previous two, and until we reach all the way to the bottom, where n either equals 0 or equals 1, and then we climb back up to the top to find the last value of fib n. And thanks for watching. Please visit our vikinginitiative.com website for more AP IB resources. And if you have any questions, join the AP CSA group chat and ask our tutors.